In this video, we will continue our discussion about scale as it relates to models focusing on speed. Although this video is focusing on speed, we will briefly introduce velocity and acceleration. Let's start by introducing speed. For this video, we will simplify speed to equal distance over a given period of time. This is written like an equation because this is also how we will solve for speed in this video. So if this was an equation for us to solve, an example of the solution would be meters per second. As written, meters per second is distance for a given period of time. It's also worth noting that speed is considered a scalar quantity. Speed is a scalar quantity because it is described only by the magnitude. In this example, the magnitude would be the value of meters per second. Again, we see distance and time because that's the data that we needed to solve for speed. Next, we have velocity. As seen, velocity can also be measured in meters per second. What's similar about velocity is that it again includes distance and time. What you'll notice in this row of data is that velocity also includes direction. Because velocity includes magnitude and the direction, velocity is a vector quantity. Now we have acceleration. Acceleration is measured by meters per second squared. The per second squared includes the change in velocity over time. What this means is that acceleration would include everything it took to define velocity and also consider that there was a change in velocity. This change could be the magnitude of meters per second and/or it could be the direction. When that change occurs, there's also another period of time to consider. That's where the per second squared comes from, or if it was written out, it would be time multiplied by time. For the remainder of this video, we're going to focus on speed alone, which is distance over time. And also for this video, as it is written, it could actually even be considered the average speed. Now let's start with our examples of speed. If an object traveled 1 meter in 1 second, the object would have a speed of 1 meter per second. Now we can see 1 meter per second converted into different units of measurement. These include feet per second, kilometers per hour, and miles per hour. In this view, we can see 1 kilometer per hour converted into different units. And in this view, we can see 1 mile per hour when converted into different units. Now that we've seen 3 examples of speeds and conversions individually, we can see a table of data with them listed together. While they are listed together, we will consider these examples at a scale of 1 to 1. Please keep in mind that this video is a continuation of our previous videos on scale. Those videos will be linked in the description. In this video, we have the same 3 examples at a scale of 1 to 1. What we've added is a scale of 1 to 10. Please keep in mind that we will use a 1 to 10 scale for theoretical examples in this video. An example of 1 to 10 scale models could be a radio control car or RC car. So let's discuss this with an example. We could have an object like a car at a scale of 1 to 1 traveling 1 meter per second. Next, we have a scale model of the object, which is a car at 1 to 10 scale. The 1 to 10 car traveling at 0.1 meters per second would be a true speed. That being said, we could use this table. We could see that the 1 to 10 car traveling at 0.1 meters per second could give the illusion, or just in conversation, would be equivalent to a 1 to 1 scale car traveling at 1 meters per second. So having a table like this can be another way to describe or relate speed at different scales for modeling. This last table of data includes the same ideas about speed as it relates to scale models. The difference now that instead of 1 to 10 scale, the data includes 1 to 64 scale. An example of 1 to 64 scale models could be 1 to 64 scale diecast cars. Also, in addition to meters per second, we're looking at centimeters per second, feet per second, and inches per second. Another difference in this table is that we're starting off with simple values for those units of measurements from 1 to 64 scale and then comparing them with 1 to 1 scale. So as seen, instead of starting off with 1 meter per second at a scale of 1 to 1, we're starting at 1 meter per second at a scale of 1 to 64. Thank you for watching this video about speed and scale in modeling. If you haven't yet, subscribe now. Comments and likes are welcomed. Thank you for watching.